You know that feeling when you finally get it?
Oh man, the perfect AI image. The lighting is stunning. The layout is just flawless.
It is pure magic.
Yeah, it really is.
But then you look closer. Beat. There is one tiny typo.
Ugh. Always. Just a single letter.
So you ask the AI to fix it,
Mm-hmm.
and it completely destroys your entire masterpiece.
Every single time. It's the ultimate regeneration roulette. And, for years, we just accepted it.
Welcome to today's deep dive. We are dissecting a really fascinating guide today.
Yeah, a total game changer.
It was published in March 2026 by Max Ann. We are looking at his JSON blueprint method.
Right.
Our mission is to extract an image's technical DNA. We're going to use Google Gemini to surgically edit photos, and the best part is you will never lose that original vibe.
Right, and you actually get to keep your sanity intact. It's a massive paradigm shift for anyone making digital art.
Let's start with the core problem. Max Ann calls it regeneration roulette.
Yeah.
And it is a deeply painful experience.
Oh, it's the worst.
You spend 20 minutes tweaking a prompt. You finally get the perfect layout. The colors are incredibly precise.
The atmosphere is just singing. Everything is exactly where you want it.
But then you spot a minor mistake.
Right.
You just want to change a coffee mug on a desk.
Right.
You want a water glass instead.
Mm-hmm.
So you type a simple command. You tell the AI to change the mug to a glass.
And the AI just panics.
Wow.
It doesn't just swap the object. It rebuilds the entire scene from absolute scratch.
The lighting shifts completely.
Yeah.
The character suddenly looks different.
Exact.
The artistic magic you captured is just gone.
Yeah.
You're forced to either accept the error or start over completely.
It feels like you're kind of wrestling smoke. You think you have the image pinned down,
Yeah.
then it just slips away again.
I have to offer a vulnerable admission here.
Oh.
I still wrestle with prompt drift myself. Beat. I try to make one tiny surgical tweak to a scene, and suddenly the whole foundational structure just falls apart.
Yeah.
The atmosphere I loved completely evaporates. It's incredibly frustrating.
Yeah, we all do. Right now, prompting an AI is like trying to bake a very specific cake,
Right.
but you're just yelling ingredients at a chef who is locked in another room.
And that chef has a terrible memory.
Exactly. You yell, add chocolate, and they decide to bake an entirely new cake from scratch.
They change the flour. They change the icing.
Yeah. To stop this guessing game, we really need a radically new approach. We have to look under the hood.
We must lock the image data down completely. We need the exact chemical formula for the cake. 2-sec silence. Why do AI models default to starting over instead of just patching the mistake?
Well, because natural language forces them to process the entire prompt creatively every single time.
Right, so they recreate from scratch instead of just patching.
They literally can't help themselves. Their core architecture is built to hallucinate from noise.
This brings us to the technical solution. Enter JSON and a highly specific AI model called Nano Banana 2.
The name is completely ridiculous, I know, but the technology behind it is incredibly serious.
Let's define JSON first, keeping it very simple for everyone.
Sure.
A text format that organizes data into neat, labeled categories.
That is the perfect way to look at it. No coding required to grasp the concept.
Think of it like stacking Lego blocks of data.
Yeah.
You build a massive, intricate castle. Later, you decide you want to change a single window. You just pull that one specific piece out. You don't have to smash the whole castle to do it.
That's exactly how this workflow operates. And this is where 2026 really changes the game.
Right.
Early this year, Google released the Nano Banana 2 model within Gemini.
It is a milestone moment for image generation.
Huge. It's the very first image model natively optimized for this data structure. It ingests C2PA-compliant JSON metadata directly.
Let us quickly clarify that term for the listener.
Yeah.
C2PA compliant, basically a secure digital stamp proving an image's origin and edit history.
Right. It provides a verifiable trail. But the key here is the JSON metadata. This model reads the blueprint natively. It doesn't just look at the pixels. It looks at the underlying math.
Meaning it is 3 times more stable than older models.
Yeah.
Things like DALL-E or Midjourney just guess what you want based on vague words.
Nano Banana 2 doesn't guess. It follows exact, structured instructions.
It reads the labels.
Right. It reads the specific coordinates for where a shadow should fall. It gives you deterministic technical control.
Not just wild creative suggestions. Beat. Now that we have this structured Lego block blueprint, how do we actually use it? How do we fix that frustrating typo from earlier? Beat. Does the listener actually need to know how to write code to do this?
Not at all. Gemini extracts and generates the code entirely behind the scenes.
Got it. No coding required.
Yeah.
The AI handles the translation.
Yeah, it does all the heavy lifting for you. You literally just talk to it.
Let us look at the first practical use case. Fixing text on intricate infographics.
This is an absolute lifesaver for marketing teams.
You generate a beautiful, complex infographic. But there's a glaring typo in the main heading.
Right.
It says translunar inaction. It completely missing the J.
It happens all the time. Text generation is still notoriously finicky.
Maxen outlines a specific master prompt in his guide. It is designed to extract the JSON. You just upload your image to Gemini.
Yeah.
You paste this master prompt. It essentially says extract all visual information and format it as a structured JSON file.
Right. And Gemini spits out this very clean text file. It's actually fascinating to look at.
It has specific data fields for absolutely everything in the image.
You literally see coordinates. You see hex codes for colors.
And crucially, you find the text fields. You locate the line that says text content in a JSON.
You just edit that text directly in the data block. It's exactly like editing a standard Word document.
You just type the J, you fix the word to injection, and you feed that text file back to the AI.
You tell Gemini to regenerate the image using this newly updated JSON, and you re-upload the original image alongside it as a structural anchor.
The result is entirely surgical. Only the text updates.
Exactly. The layout stays perfectly intact.
The fonts do not change. The kerning remains the same.
The background gradients don't shift a single pixel.
There's a brilliant bonus application buried in this workflow.
Oh, yeah.
You can seamlessly translate a full English infographic. You can change it into Spanish or Portuguese or Japanese.
Right, and you do it without doing any Canva juggling. You don't have to manually replace text boxes and realign everything.
You just update the text fields in the data structure. The AI handles the entire rendering process. The original design remains completely untouched.
It really is like magic. You save hours of tedious alignment work.
Fixing text is a great starting point, but text is relatively flat.
True.
The real power of data manipulation reveals itself when we step away from text.
Yeah.
When we start swapping out physical objects in three-dimensional space. 2-sec silence. What happens if my translated text is significantly longer than the original English?
Well, the design template won't expand automatically, so the text might overflow and break the layout.
Makes sense. Keep the word count similar to avoid overflow. Sponsor. Welcome back. Let us explore the second major use case from the guide, surgical object swapping.
This is where the workflow gets incredibly powerful.
Okay, fixing a typo is great because text is flat. But what happens when we introduce 3D space and shadows?
Right.
Imagine a generated scene. It has beautiful warm lighting, a perfect moody atmosphere. There's a silver laptop sitting on a wooden desk.
You suddenly realize you need a vintage globe instead of a laptop for the campaign.
We know natural language completely fails here. If you type, replace laptop with globe, it ruins the lighting.
It breaks the mood entirely. The AI redraws the whole room to accommodate the globe.
So we use the JSON blueprint method instead.
Yeah.
We extract the scene's full technical data.
We get the precise lighting coordinates, the exact color palette, the specific background details. It's all mapped out in the code.
Then we feed that extracted JSON back to Gemini. And we add one very short instruction. Change the laptop to a globe.
Because the JSON acts as an unbreakable structural anchor, the globe replaces the laptop perfectly.
The warm lighting remains perfectly intact.
Yeah.
The color palette stays exactly the same. The background books in the window frame are 100% identical.
Right.
The globe even casts the correct shadow because the lighting vectors were locked in.
Whoa. Imagine scaling this, perfectly locking in that exact golden hour lighting for 1,000 different shots.
Yeah.
You could build an entire brand identity around one perfect lighting setup.
It is a profound level of granular control. It anchors the scene completely in mathematics, not just vibes.
It really turns the AI from a slot machine into a professional tool you can actually trust.
If we can perfectly lock down the lighting for our own generated scenes, it raises a very interesting question. Can we steal that perfect lighting from a professional photographer's real-world image beat? Why does this work so much better than just typing, keep the lighting the same?
Because natural language is treated as a creative suggestion, whereas JSON is treated as absolute technical law.
Words are for creativity, but data structures provide exact control.
Right, and that exact control changes everything we know about editing.
This brings us to the third use case. I consider this the pinnacle of the method. cloning professional photography styles.
This workflow feels almost like having a superpower.
You see a stunning, award-winning photo online. The lens choice is incredibly specific. The color grading is deeply cinematic. The subject is backlit perfectly.
But you don't have a photography degree. You have absolutely no idea how they actually lit that scene in the studio.
You don't need to know.
No.
You just upload that professional reference photo directly to Gemini.
You use the master prompt to ask for the photography JSON?
It analyzes the image and details the likely lens type. It maps out the lighting setup. It extracts the color grading values into hexadecimal codes.
It pulls the exact mathematical recipe of that aesthetic.
Then you take that extracted blueprint and you apply it to your own casual selfie.
Yeah.
Or perhaps a basic green screenshot of a product.
Gemini analyzes your flat selfie. It reads the professional recipe you provided in the JSON. And it forces those lighting vectors onto your image.
Hold on a second. I need to push back on this. Lighting is actual physical physics. If a professional photographer used a massive bounce board to light a model's cheekbone in a studio, and I'm just taking a quick selfie in my dim basement.
Yeah.
Gemini cannot just JSON a bounce board into my room. Does it actually look real, or does it just look strangely pasted on?
That is a brilliant question. It doesn't paste a physical bounce board, obviously.
Right.
It extracts the lighting vectors from the JSON. It reads the data of how light hits a curved surface in the reference photo. Then it remaps those mathematical highlights and shadows onto the topography of your face.
So it is simulating the physics based on the blueprint.
Exactly. You instantly clone the professional look.
It matches the lighting direction.
It matches the depth of field. It adopts the exact mood of the original masterpiece.
This introduces a fascinating new concept for creators, a layer-style editing workflow.
Right. Because once you have that JSON structure, you can iterate endlessly without breaking the base layer.
You find the absolute best generated frame of your newly lit selfie, you download it, you feed it back in and use it as a locked reference blueprint.
Then you just change one variable. You say, change the subject's outfit to a tuxedo.
The face stays exactly the same. The complex cinematic lighting stays exactly the same.
Only the clothes change.
You are editing in isolated layers, and you are doing it using a simple free AI chat tool.
You're bypassing complex software entirely.
This level of granular control feels limitless when you first discover it.
Oh, totally.
But to use it effectively, we need to understand the realistic boundaries. We must know where the blueprint method actually breaks down. 2-sec silence. When you apply a style to your selfie, is the very first generation usually flawless?
Usually no. You still need to run it 2 or 3 times to lock in the perfect pose and expression.
So you still need a few tries to nail it.
Yeah, iteration is still a necessary part of the process.
Let us ground ourselves in reality here. Let's discuss the actual limitations of this technology, what it can and cannot do.
It's incredibly powerful, but it's not a magic wand for every single problem.
JSON editing is incredible for one specific thing, attribute isolation.
Text edits, small object swaps, lighting and style cloning. It isolates those variables beautifully.
It excels at those surgical tweaks, but it fails completely at massive structural redesigns.
Like if you want to change the entire layout of the image.
Exactly. Or if you attempt major layout resizing.
Right.
If you have a vertical phone wallpaper blueprint and you told the JSON to make it a massive horizontal billboard,
it struggles deeply. The entire image warps and breaks.
The structural templates do not automatically resize themselves intelligently. The data coordinates get confused.
The ultimate rule of thumb here is quite simple. Make one surgical change at a time.
Do not rush the AI.
No. Step-by-step iteration is the key to maintaining the lock.
Knowing these exact boundaries is what allows us to truly progress as creators. It lets us finally move past the era of endless, frustrating prompt guessing. It helps us summarize the real paradigm shift happening in 2026. Beat. Why does the AI struggle so much with large structural edits using this method?
Because a blueprint is inherently rigid. If you try to move the foundational walls, the whole house collapses.
Right, you can paint a room, but cannot move walls.
Exactly. You have to respect the underlying structure of the data.
Let's reflect on what this all actually means.
Yeah.
The core takeaway from Max Asguide is profound. The era of professional AI imagery in 2026 relies entirely on attribute isolation.
That is the defining term of the year, attribute isolation.
We are transitioning away from the concept of drawing. We are no longer just painting with vague, hopeful words.
Right.
We are treating an image Exactly like a spreadsheet. We are precisely modifying specific technical values.
We change a single data point in a text file. The corresponding pixel cluster updates.
The rest of the image ignores the change.
It's a fundamental shift in how we interact with creative machines.
We are moving from stochastic random guessing to deterministic absolute control.
You really have to try this workflow yourself to believe it. Open Gemini today.
Mhm.
Upload a professional photo you deeply admire. Ask it for the photography JSON just to see how deep the rabbit hole really goes.
It will completely change how you see digital images. 2 sec silence.
Okay.
I will leave you with this thought to mull over.
Okay.
If an AI can perfectly extract and replicate the technical DNA of any professional's signature visual style in a matter of seconds,
Yeah.
what does that mean for the future of artistic copyright and the intrinsic value of a photographer's unique look? Outro music.